So last video we looked at the beginning of 6.2, and now we're going to look at the rest of section 6.2 in the text, textbook. Remember, it's about definite integrals. So an integral is the name for this. So let's just quickly remind ourselves that this means, the meaning of this, excuse me, is that we want to find the area under the curve on the interval under the curve, f of x on the interval from a to b. Okay, so this is just an elongated s, right? It stands for the summation, right? Find the sum of all those infinitely small rectangles that we have there. We saw excuse me, then we were doing this last time. We don't always actually have to have rectangles, right? We can just make the shape. Okay, so today we're going to talk a little bit about what you can do if you can't make the shape, excuse me, or if the shape's broken up, something like that. Okay, so let's start with this one. This is similar to a homework problem, like this. Okay. So let's do this as our first example. Now we look at this and we're saying, oh geez, I'm not sure what this graph looks like. And so what the suggestion I made online, when if you tried this problem already, it's just to plot some points. So let's plot -4. So if I plug in -4, the top is 4 over -4. 4 over -4 is -1. Just plugging in the point. If I plug in -3, this would be 3 over -3, -1 again. If I plug in -2, -2 becomes 2 on top, -2 on the bottom, so it's -1. Same thing with -1. If I plug in 0, oh wait, I can't divide by 0. It's 0 over 0. It tells me I'm missing something. If I'm looking at it, right, my graph is kind of coming up. If I plug in like -0.001 to that, this becomes positive 0.001, and this is negative 0.001. Divide those, is still -1, so we can see that it's going to be infinitely close. If I plug in positive 0.001, right, then the top is going to be positive, and the bottom is going to be positive. It's going to be the same number, so it's going to be approaching 1. Excuse me. So if I plug in all these values, I plug in 1, I get 1 over 1, that's 1. If I plug in 2, right, 2 over 2 is 1, right, 3 over 3 is 1, 5 over 5 is 1, so it looks something like this. Okay, so I did a whole bunch of graphs, but as it got close to that domain restriction, I just plugged in something infinitely close to help me there. Right, that's what you can do with domain restrictions. Looking at this, what's the area? Okay, the area of this is a base of 5, a height of -1, so the area is -5. So if you get an area of -5, remember we're finding area under the curve. All that means is that you're actually below the curve, right? And so you see the area is actually kind of, right, I'm sorry, that you're actually below the axis, and the area is actually kind of above the curve there. I'm sorry, that was 4 right there. This is 5 by 1, positive 5 by 1. So the total area here is 1 for that. Another one that might be hard to think about the graph, if I did -2 to 3, and the greatest integer function. All right, this can also be written, like in the textbook, they sometimes write it this way, int of x. Okay. So if I think of that graph, hopefully you remember, but we haven't done it for a while, but that's a step function. And so the step function steps up at all the integers. Okay, remember, basically it's rounding down any decimals to nearest integer. So when you plug in like 0.6, rounds excuse me, 0.6 by the x value rounds down to 0. If I plug in 1.1, it rounds down to 1. If I plug in 1.7 as an x value, it rounds down to 1. So it gives you these steps. Okay, let's see, -2 to 3. Okay, That step is -2 as an area. That step's -1. That step's 0. That step's +1. That step's +2. My area is 0. So there's no, the area under the curve is 0. Okay. So just a couple. You just have to graph it. Right? And you'll see problems like that are what numbers 37 through 40. So when you do numbers 37 through 40 out of the textbook, right, they're going to be just like that. So you kind of have to graph it out, maybe reduce a fraction there, whatever. Okay. If we're looking at ones like 33 and 34, okay, and let's say we have something like this. Right? Now, from what we did in the last video, we know that that's a circle, right? Circle with a radius of 5. But the problem is, this is going up to 3. So if we were to graph this one, right? Circle center is 0 with a radius of 5. 0 to 3 would only take us to here, and that's a problem because it's kind of like a nondescript spot here. So we can't, if we did that whole section, we could say that's a quarter of a circle, but we can't say anything about this portion of the circle. So this is when we use our calculator. Okay, now your calculator is newer than mine, so it's the same button that you're going to press, just might look a little different. So the calculator can evaluate this one for us. So if we hit math, and then we go down, and it'll say FN int on mine, right? And yours might say something different. It might look like this. Something like that. Okay? And that's going to do the same thing. So yours actually makes more sense than mine. Right? Or maybe if yours says FN int, it'll like pop up as this notation. And you'll just plug this all in, okay, for yourself. Right? And how would that, like for mine, right, I have FN int, as I said, it's harder, right? You would enter the function in, right, no matter what, you're going to enter that function, so you're going to hit square root, parentheses, 25 minus x squared, close parenthesis, okay? Now, yours might also have a box right here. Usually it has a box right here. That tells you, it means it wants to know what variable is, so you're going to put an x there, okay? And then you put the lower bound in, which would be 0, and the upper bound 3. And you just hit enter, and it'll calculate it, and it'll give you about 14.04. Okay? And so if you saw, when you see a problem like that, all I want you to use is just be able to, hey, use your graphing calculator to evaluate these. There's some that are going to ask that. So it's just about keep plugging it in. Okay? So again, you go to math, go to the math key, okay, you go down to number 9, which is FN int, means you're integrating the function, okay, and then enter the function variable and bounds, okay, and it'll pop out a number there for you. Okay, so those are going to be like numbers 33 and 34. Notice 33 and 34 say use n int. That's the same thing. That's just an integer, an integrating function. That's a general name for it. Okay. Other things you're going to be asked to do. I'm going to leave that. That's not okay. You might have a question like this. Find, oh, I'm sorry, this is not just 33 through 35, this is 33 through, actually, so find the area, under the curve, And so this is just putting the problem and what we've been doing into words instead of into notation. So you need to know, like, hey, area under the curve, that means I'm integrating. And there's the function I'm integrating. I'm integrating it in terms of x, so the dx goes there, right? That's the width of all the little infinitely small rectangles, and it's going from 3 to 4. And then you would put that into your calculator. This section says, hey, just put it into your calculator. So you go math, number 9, to get fn int. Put in your function. Make sure you put an open parenthesis before you put the function in. Just plug in all that information, and you'll get about, actually this comes out to exactly 8.6 repeating for yourself. Okay. You know, if there's a trig function, just put a trig function in there, making sure you're in radians version form. Okay, so that's like 35 and 36 when you're doing those. Okay, so just going through the different types of problems that you still have to look at. Okay, the last one is going to look like this. Right? Actually, I'm not going to do the last one this year for you guys, right? And that's basically what we're going to end with. Okay, so we'll just go from there. So good luck on those problems.